Thank you for being here on the panel. Really appreciate all of you here. Good thing is we really got researcher, startup, and an investor in this panel. So it completes the ecosystem of research in the industry, if you will. So excited to have you here. What I wanted to see was, for each of you to talk about what you do in your space, about 3 to 5 minutes, give a background of yourself, and then we can take from there some questions. So starting with Dr. Foster.
Sure. Okay, thank you. I guess you can hear me okay. So as mentioned, I kind of started my career at Sandia National Labs. There I was a code developer, writing computational mechanics codes, physics-driven computational mechanics codes that could exploit the DOE supercomputers. Did that for 7 years. Moved to academia in 2011. And just coincidentally, the same year I wrote my first piece of Python code. Before that, I was mostly writing C++ and Fortran and other things. Shortly after coming to academia, or moving to Austin, I befriended Travis Oliphant, who most of you probably know, or at least implicitly know, because he was the creator of NumPy. Anybody who's written numerical code in Python knows NumPy. Also co-creator of SciPy, co-founder of Anaconda, et cetera, et cetera. But our friendship kind of led me more into interest in data science and machine learning. So I've been working on that ever since. A few years ago, 2018, co-founded a research consortium in the Hildebrand department at UT with my colleague, Michael Perch, who's a geostatistician, where we work on subsurface data analytics and machine learning problems. We've have a group of about 15 PhD students between the two of us that work on applications of data science and machine learning in subsurface. So we do, again, he's a geoscientist, so he's doing a lot of reservoir modeling. For example, using GANs to generate reservoir models that are conditioned to well logs and seismic data, seismic upscaling, other things like that. I primarily work on, mostly interested in scientific machine learning, so coupling physics or adding physical constraints. Physics-informed neural networks are one example of that. Can talk more about that later if we'd like to talk about that. But basically, as was kind of alluded to in the previous question that you asked, actually, not only is our subsurface data messy, it's really biased. It's we only sample like 1/1,000,000th of the subsurface. If you want your data to be less biased, you got to convince your boss to just go drill a well in a random location, or hundreds of wells in random locations, and I don't think anybody's going to do that. So our data is always going to be biased, and so so adding some physical constraints in that can really regularize the objective functions of our models and help things out a lot. So it's one thing I've learned. On the education side, I teach our petroleum engineers programming, reservoir simulation, high performance computing, including parallel programming with MPI and GPUs. So I get to see, a lot of our students coming out are really, or in the last few years, really have an aptitude for programming and really excited about data science and machine learning, coming right out of our petroleum engineering program. So I don't think you need to go look at computer science programs necessarily to get, machine learning engineers. They're coming out of our petroleum engineering program at UT. And then the last thing you mentioned, also, with my same colleague, Michael Perch, we co-founded a company called Datum, which is, essentially we built a data science and machine learning education curriculum all around oil and gas data. So we have a big production data set that's kind of equivalent to Enverus or IHS Markit type data, and as well as a lot of petrophysical data, some seismic, and then we basically built an entire, from your first line of Hello World Python program all the way through GANs and neural networks and everything else. Not all in one course, we have several different offerings, but all built on top of oil and gas data. So, stuff that's familiar to working, petroleum engineers, reservoir engineers, those kind of people. And I've had a lot of fun with that. It's really fun teaching working professionals. You get to learn about their problems. And you get to see the real return on investment is actually just in a lot of data pipelining and automating workflows. I would say the number of people, we've taught now over 2,000 people, working professionals, and I can't name one instance of one of those people like deploying within their whole companies in the cloud some production machine learning model that's changing the way they do business. But many, many of them have automated thousands and thousands of hours out of their daily jobs. and a huge return on investment in that just by knowing a little bit of code. And of course, nowadays we have generative AI to help us write a little bit of code. And so things are, in my opinion, there's never been a better time to get into this space to learn it. The tools for learning have never been better than they are now. So yeah, I think that's enough for now. Yeah.
All right, thank you. Thanks for that. And it's interesting because Dr. Cohn presented more on the process side. It's super instrumented systems in general. There's a lot more you do there with the data, but like you said, subsurface data is a whole different beast. It's lots more data, lots more calculations, but then the data isn't available necessarily. It'd be good to talk about that. Vivek, how about you? Can you talk about yourself and what you guys do?
Yeah, so like Prabhu mentioned, I used to be at DeepMind and in Google for a decade before doing Xcarta. My job there was what I call applied machine learning, which basically meant looking at fundamental research teams and the things they're doing that have 5-year time for making some actual techniques work, and identifying which real-world problems can be solved with those techniques that maybe needs a bit of work to make it work in the real-world constraints, but there's some outsized impact if we can actually get it deployed in the real-world situations. At Xcarta, for the last year and a half or so, we've been using AI to improve the quality of weather forecasts, and it's basically using self-supervised learning to learn how to forecast the weather up to 2 weeks out at high resolution, high accuracy, high quality, at a fraction of the cost and time it takes to run these models in a supercomputer. And just for context, some of the biggest supercomputers in the world today are used for weather forecasting. These AI models can make a forecast just as good on a laptop GPU for you. So there's a lot of benefits coming from the kind of speed and accuracy improvements. And what we are able to benefit a lot from is just this huge amount of advancement in the LLM space. All the techniques that work there seem to work well for weather as well. Plus, we have the benefit that weather is a very well-studied field. We've been doing this for 70, 80 years now. A ton of good data, a ton of good baselines and benchmarks, and a lot of good, really good physical models that serve as emulators. So alluding to the previous talk, we have some very nice ways of verifying if our models are actually representing the real world correctly or not. And there's a bunch of applications in the energy space where we feel like energy is fundamentally in the physical world. You can't escape the impact of weather. So if you need better forecasts for wind and solar farms, that's where weather comes in. If you need better forecasts for demand on the grid, that's where weather comes in. If you have both of these, you can reduce carbon impact by turning on your coal plants and natural gas plants only when you need to and not all the time. There's also this whole question of operational impact. So where do you think your utility might face an outage? Where do you think that the hurricane might interrupt your supply or delivery of resources in offshore operations? So it's pretty exciting because we're seeing a huge amount of work in the AI field for how do we improve weather forecasts for all of these applications, and really for the first time able to exploit the petabytes of data we collect for weather every single day. And this is one of those lesser known facts for weather. We collect a lot more data than we actually use. We throw away most of the things we collect from satellites and radars, and for the first time it looks like these ML models can actually exploit those data fully. So it's pretty exciting to be here. Happy to share more if there are questions.
Yeah, that's super interesting. So one good thing is in weather forecasting, hallucination of generative AI won't be different to what we hear from the weather forecasters on TV. But more importantly, so you talked about some of the, I'd like to come back to some of the, usage. How are actually people using it today versus, when you bring in weather forecasting into, let's say, LNG performance, because LNG performance does change by diurnal cycles. The weather has a big impact. Historically, people haven't leveraged that in the optimization techniques. But that adds an extra level of complexity beyond just the performance of the unit itself, but now you're imposing the environmental conditions on it. Are people actually leveraging that, today, where they're using it to do the optimization? Because to me, that includes a higher level of complexity than what's being handled today. So can you talk about that a bit more?
Yeah, it's a fantastic question. In fact, we actually see when we talk to consumers of our weather forecasts, I think there's still a spectrum of sophistication in the adoption as well. So there are some companies who are themselves very much on the right end of the bell curve in AI adoption in their own internal workflows. So effectively, when you talk about weather forecasts, it works well for consumers who can use raw data better because weather forecasts are raw data. So there is definitely like a tail end of consumers for whom it's like this is all they need. They have their own ML pipelines that can use them. But for many of the folks we work with, we feel like there is a loss of value that happens because there is, like you mentioned, a non-trivial process to make the weather data actually useful. So that is a challenge for sure.
Yeah, I mean, my experience in one of the projects my team worked on, in my previous job was where there was a Apple storage facility, real apples. We're not talking about Apple, the product company, but real Apple storage, and where they were essentially having a solar farm and trying to optimize whether to buy from the grid or use the solar energy because there's a finite capacity to store and release, and there's a release cycle as well impacts the life of the batteries. So it was a fairly complex problem, and a lot of that had to use forward-looking weather forecast to then make the decisions today on how you optimize, your decisions. So I can see that being a great place where you could potentially leverage the weather forecast more accurately, because what we were doing in that project was really using past, at this time of the year, what was the average, data, and then kind of leveraging that to use it with current, but then the prediction probably can be better using something like what you're talking about.
Yeah, if I can add one more point before we pass on to Christy. I think a decade ago, my master's thesis project was how do you decide to sell or store wind power depending on the forecast for the next 2 days. And at that time, there was not much storage on the grid, so it didn't really matter because you kind of had to sell or not produce. But now there's more solar storage being deployed, especially in Texas, so that becomes more relevant. Like, do you store or sell depending on do you have more solar power coming in the next few hours and what the price of electricity might be. So that's also where RL is really helpful, because it's not like there's a single best choice. You have to decide what your reward is, maximum revenue, given you have at least X amount of reserves. So it suddenly feels like there's more physical infra that can actually benefit from ML as well.
I have a comment on, I know I haven't introduced myself yet, but just on the value of weather data. Now that solar and wind are such a big part of the grid, all of electricity is dependent on how renewables are setting price. And the way that those, the way that those plants all get underwritten is based on weather forecasts. And so they're such low risk assets. The solar panel just sits there and soaks up sun, that they're heavily debt financed. And so the banks come in and they look at these projections for the weather, which have in the past, we've been wrong a lot. That creates problems for the insurance, creates problems for the debt, creates problems for really the whole ecosystem. And so if you get the weather forecast wrong, then you have these projects going under. And anyway, the point being, weather is a massive element of financing. And now that you have energy storage tied to the renewables, those weather forecasts also influence the financing of natural gas plants and fossil fuel plants, because your base load is is renewable. So, and also from a nonprofit perspective, like, is the climate, what's going on with the climate? Are we gonna make it out of here alive?
Yeah, it's good to know. So Christy, if you can talk about your background and what you do, and we can have some questions around that as well. So why don't you introduce yourself now?
Sure. So my background, I am not technical. I have ventured into this technical world that you all live in, and I am learning a lot. My background's in finance. I grew up in Texas and got right into conventional energy. And then moved into clean energy power in large-scale infrastructure. So that's where I learned a lot about just how you underwrite, how the banks and equity behind these big, giant power, transmission, distribution, storage, even like hydrogen fuel cells and securitizations. Like, how do you efficiently make this stuff work in the money world? And then I appreciated that I didn't feel like we were innovating enough in energy, and so I moved into venture capital. And so that's what I've been doing for the last several years, and I have gotten closer and closer to, I guess, the cutting edge, in part because there's such an enormous amount of activity happening specifically in energy at the very beginning, in the universities and the research labs, and there's kind of this renewed interest over the last couple years since COVID to innovate in a space that's been historically difficult to innovate in. So that's what I'm doing now. I invest in startups. I also have co-founded a nonprofit arm that we're actually spinning out that is focused on getting research into the market. And, how do you take these pieces of technology or an angle to a solution of a particular problem, let's say just solutions, into the real world. And it's, easier said than done.
Yeah.
What I'm paying a lot of attention to these days are I think weather is one, definitely. I think there's a huge benefit to the financial sector. Material science innovations. The material science innovations that can be driven by AI will kind of bridge between this atoms and bits gap that we have in energy. We have to do stuff in the physical world here, and that's just kind of part of the game. Grid solutions, energy infrastructure planning. A lot of people are trying to figure out, how do you map out EV charging stations with this kind of added layer of uncertainty in that hydrogen and there are other forms of energy and fossil fuels that how does that equation work out, and do we get disrupted, do we not? And
Spot pricing on that, right? Because it takes 15 minutes to charge, maybe 20 minutes, so you got to go stay.
time of day,
Yeah.
So the point being, lots and lots and lots of data.
Yeah.
So you really need.
So on that, since I see a lot of young folks here, maybe one thing you could add is, what do you look for? AI today feels like for some of the older timers here, I suppose. The days of early 2000s and the crash that happened. It's like AI everywhere. There's a lot of funding. What is it that you look for in a startup that when you want to fund it in the AI space? If you can, see some young folks here, it'd be good for them to understand that.
Yeah, I pay attention to team, tech, traction, and market. And then on top of those, and this is maybe, not the most important, but a very critical element, is how are you going to get to market? In energy, it's more difficult because you have a capital-intensive industry, you're regulated. It's really important. There are strong incumbents both on the kind of legacy energy side and power side, and so you have to work with them. A lot of times the technical minds that are able to figure out how to come up with a good idea good enough to build it into a startup are not necessarily those that understand different elements of the market and the relationships that you require in order to make stuff really happen. So that's the kind of stuff that I look for. I think it's tough. There is sort of a hype wave going on in venture right now in AI, or generative AI, maybe, let's say. So much of venture capital was like enterprise software. And so now all that enterprise software needs that in expertise, and capital needs a new place to go. And AI is just a really logical place for it to move into. And so there's tons and tons of attention. I think it's a pretty tough space to make a play on, although in sectors like energy or, that are a bit off the beaten path, there are opportunities to be had, but yeah.
All right, thank you. Dr. Foster, from your perspective, one of the things that fascinates me in this space is the fact that historically, a lot of research went linearly historically from university to then fundamental research, then application, JIPs funding the university to find real applications, and then for it to be productized. The whole cycle was probably about 20 years, but that cycle seems to be so much shorter today. And what's your experience in that space? And it also feeds into the funding mechanism, because the pace of change is so rapid, and you're constantly getting disrupted. So it would be interesting to understand, as a founder, as well as a researcher, how do you see that space? Because a lot of research also seems to be happening in the industry and going into research.
Yeah, I would say, in fact, a lot of what I do, as much as I hate to admit this, is not truly original research. It's taking a lot of things that have been developed in tech, at DeepMind or elsewhere, and then looking for applications in oil and gas, right? Or in the energy. I also work on subsurface hydrogen, so anything subsurface, right? So I think some of the best research is actually being done, and some of that is the incentives in academia are not to build products, right? It's to publish papers, essentially. So that's some of the problem that we need to fix internally. You know, like faculty should be promoted and adored, not just simply for publishing papers, but for building tools that people are using. So the last speaker mentioned that, you know, the current hype or, you know, excitement about AI is driven by neural networks. I would argue that it was driven by neural network frameworks being released to the public. I'm talking about PyTorch and TensorFlow and JAX and, you know, Flux if you're a Julia person like me. But it's really the tools being released to the public to make it easy. And of course, those are all built on GPU computations, et cetera. So that's part of that story too.
But also things like now the physics-informed neural networks coming out of Brown University and Michigan's doing something in that space as well.
Yeah. There were some papers in the 90s on radial basis function neural networks solving PDEs. So the Brown work, they just coined a great name, right? With a good acronym.
It's funded a lot by NVIDIA.
Yeah. So I don't know if that answered your question, but I would say that you know, I think there's great work being done in tech, and in some respects, you know, in academia, we're actually, you know, see that research as peer level.
But you're using the computational research work that's been done in the industry to apply to fundamental research to solve industry problems in the energy industry.
That's
right?
correct.
Like that's what you're okay.
Yeah, that's correct.
Okay. About you, Vivek, you know, tell me about your experience as a startup. You know, how you took, you know, did you take fundamental research into the market? You know, tell me about that experience as well.
Yeah, definitely. I think, like John mentioned, we do rely a lot on the fact that there is excellent research being published by research labs in academia. I think the main difference we see is that the mandate for those organizations is not to make a product out of it at all. So the cycle doesn't necessarily go back from users who might want to use that to what more research needs to be done. And to give you some very concrete examples, like the fundamental breakthroughs in weather modeling showed that you could do 10-day, 2-week forecasts, but they didn't bother doing forecasts for every hour, because if you can do it every 6 hours, that proves the point. And in real-world settings, you actually need hourly forecasts. You also need it for many, many more variables than just like the basic 4 or 5 subsets. So that's where we do a lot of work identifying, like we build these models and customers tell us like, actually I need solar irradiance, I don't just need wind speeds. Then we go back and figure out to model that. So that there is a cycle where we end up doing novel research on top of fundamental research that helps us actually deliver a thing that people want to use, as opposed to one more paper being published, which is not our goal specifically.
Thank you. Christy, one of the things, you know, I was at COP26 3 years back, and one of the big things out of that was the finance industry basically abandoning with the traditional oil and gas energy industry. You know, we're in the kind of oil and gas capital of the world. It was quite disheartening coming out of it, being in that space for 20 years. And you know, some of it didn't make sense, because you know that any transition takes time, and it was just, and looks like the geopolitical impacts have brought in a sense of realism to what's happening in the financial market in this space. So can you talk about startups in the energy industry, oil and gas, especially traditional oil and gas? You know, what's the funding space for that nowadays, and you know how you guys are viewing that from the prism of complete sustainability, you know, sustainable solution within 10 years to, okay, there's realism, it's a bucket of energy that's needed, different bucket, you know, different pieces needed. How do you guys look at it today, and what's happening in that space?
This is a problem that I think about a lot, because just growing, you know, I grew up in Texas. I started in oil and gas. My dad, you know, like I met the CEO of Halliburton, and my dad had like he was so happy and proud, you know, like, and then, you know, in my venture fund, I'm partnered with this, she's, you know, lives right around the corner from Stanford, wears Birkenstocks, very, you know, just staunchly clean energy, uncompromising. And I think there's a real cultural divide between kind of legacy industry and clean energy. And they're kind of different worlds. You know, I understand both sides of it. On the energy side, you've got these guys that have spent their life supporting America. You know, they like have been working. I drive a gasoline vehicle. Statistically, most of you must. You know, like we use plastic a lot. Like it's something really critical to our lives. But when oil prices went negative, in COVID, I think everybody got so spooked, it sort of really shifted a lot of attention and capital towards clean energy. And honestly, if you look at even like some of the large oil and gas companies, they're distributing a lot of capital. They themselves are not putting a lot of new capital into oil and gas. And so I do think it's a complex decision to be made in terms of how you allocate your attention. I mean, for venture, most of it is going to be clean energy. But that said, venture is like a tiny little baby capital market relative to the scope of private equity itself. And there's a lot of private equity and Fortune 500 attention in the legacy energy space.
That's good to know, because one of the things, for me is when I look at conferences these days that I've been going traditionally, I was talking to Dr. Foster about this, the average age has just gone up and up and up. You don't see young professionals coming into the legacy industries, which is quite funny to watch. And but you also see that AI then has a huge impact, because if you're not able to replace, we've been talking about skills gap for a long time, but it's real. You see it when you go to conferences these days. The average age, we don't see Vivek kind of people there much these days, And so AI is going to be super beneficial for the industry, but I'd also like to see that there's more professionals coming in, because it's an exciting space for AI to be applied to really difficult industry problems that have been needing this kind of technology. So is there a good space? But the reason I bring that up is also that the industrial software space is a difficult space. It's not easy to sell in industrial space. So when you're thinking about funding companies in that space, do you look at, it's easier to go AI, generative AI for general applications versus AI applications in the actually industry, which is harder. You even see companies like Google, Microsoft pulling back their work in that space and saying, okay, ecosystem of partners do it. We're not doing this anymore because I have more money to make in generative AI. So how do you look at it from startups that come into this space trying to solve industrial problems in AI, with AI?
I think, so that's where I'm focused. I mean, I think that it's really a question of supply and demand of capital. And there's so much money racing after the easy stuff, the easy software stuff. And the easy's not fair, everything's hard, but industrial is longer sales cycles. These are not, necessarily organizations that natively understand the cutting edge of technology. They're not really suited for it. And so there's more complexity. I mean, the other piece of it, like when you think about the energy value chain, first of all, you have the two layers of legacy energy and clean energy, and then you've got upstream, midstream, downstream, distribution, shipping and transport, and then there's so many layers to the clean energy. There's so much more complexity because there's disruption risk that it just becomes really hard to figure out how to make decisions and what to go for, but I think even more difficult, how to go to market. Like, which segment of that value chain do you really need to be paying attention to first to get your stuff adopted in a serious enough way to where it's like a domino, and then all the dominoes fall and you have a big success. I think the other piece of it that's tough is there's inherently a different risk-return profile in some of these industrial applications, just because they're such capital-intensive industries. There's not necessarily going to be one solution that's going to take over the world. And so it doesn't really fit, into this risk-return mold that a lot of the money is chasing after. But that said, there's a big venture bubble bursting right now as we speak. A ton of money flooded into the space in 2021 in response to the digitization that happened with COVID. They thought that would continue on forever and everything would be digital, and it hasn't worked out that way, shockingly enough. And so I think there's a real reassessment going on right now where people are trying to figure out, okay, well, there's too much money in this space. Is that what I should be paying attention to? Where do I need to apply my attention? But these are human networks. You can't change overnight. If you've got a team of 20 that's been paying attention to enterprise software for the last 10 years, how do you pivot them into focus on energy or healthcare or, any of these other sectors that desperately need solutions? So I think that's the
All right.
trick of it.
Thank you. I'm looking at the time here. Sam, we have about 15 minutes. I think it's a good time to maybe open up for some questions to the people, audience here. Anyone has any questions for the folks? Or we can continue on.
I'm a geophysicist, so I have a question for the Professor Foster. You talk about the petroleum engineering. We do for seismic data, we do inversion. We get the subsurface structure. The resolution resolution about 100 meters, 10 meters, 20 meters. But for you, petroleum engineering, you need the resolution at the meters, even centimeters. For seismic inversion, we can say it is, I would say it is the unsupervised machine learning. But now my question, you talk about a lot of AI, how we can combine with AI, the seismic data. We do inversion, then we achieve the resolution about meters to meet your requirement. I think about the question a long time, yeah. I couldn't get an answer. So that's why I ask you this question.
Thanks. Not really my area of expertise, but my colleague, I mentioned earlier, Perch, he's worked on some generative AI for seismic downscaling. So to take the coarser scale seismic and basically use generative AI or GANs to trained on higher resolution synthetic data usually to get load models and other things. The other answer there, I think it's worth talking about too, is that in subsurface problems, the uncertainty model is more important than the deterministic model. And that's something that we never really focus, hardly, I can name on one hand the people that are working on, building machine learning models, tuning machine learning models to produce good uncertainty models, right? When I mean good uncertainty model means, if you have a machine learning model that produces a distribution of outputs, 10% of your test data should lie in the 10% distribution. 20% of your test data should lie in the 20% distribution. 30% and so on, right? So, and so we've actually in our research group, in our consortium, been working a lot on, how do we, hyperparameter tune machine learning models to build good uncertainty models, right? And so in terms of, you're again, not exactly my area of expertise, but I would say that, as long as we could build, downscaling models that produce good uncertainty, right? In the sense that, a distribution of subsurface information that is good in the sense that I just described, that's better than having a deterministic answer in the sense that, okay, there's a lobe that, transverses here and goes up 2 meters there and goes down. Like, that's less important than having the correct uncertainty model, because it's with the uncertainty model that you make decisions in subsurface.
100%.
So,
I mean, I come from flow assurance where it's much more deterministic. Yeah. We hated the reservoir engineers because we were questioned on 1 degree temperature prediction. So why did it change the next time by a degree? Reservoir engineers, completely different, 180 degree turn of output. Nobody questioned them because, it's within the uncertainty, but the decision making is based on.
And reservoir engineering, you typically just talk about P10, P90, right? And then your manager freaks out when one data point ends up outside the P90. But 10% of the data should be outside the P90 if it's a good uncertainty model, right? Yeah. So.
Yeah, I had a question for Christy. So we've talked a lot about AI in industry. Can you comment about how you're using AI to assess startups and make financial decisions? Obviously, humans have a lot of bias, and so it'd be interesting to hear.
Yeah, no, that's a good question. So I use like ChatGPT a lot. I'm working on a more sophisticated strategy. I will tell you that there is, particularly when you're dealing in the very early of startups, a lot of it has to do with the company. and so I'll come back to that, but a lot of it has to do with the market that they're playing in, and that's both from a sector perspective, but also from a geographic perspective. And because when you're dealing in technologies like AI or robotics or even energy can be horizontal in certain ways across industry, that you need to really be careful about how you make those decisions. And there's tons of data involved in kind of that level of market play choices. You know, when it comes to the geographies, you have different geographies have different levels of kind of like startup ecosystem sophistication, or different economic clusters in particular industries. So clearly we're sitting in a big giant energy cluster here, but you've got, you know, Hollywood is one, you've got AI and software, IT, let's say, out of the Bay Area, and there's just, so much of a particular startup's success can have some dependence on whether they're in an economic cluster where they can go down the street and talk to this guy and they'll talk about the right thing to do, and you know, it's where the humans are. It makes such a big has such a big impact on things. So that's predominantly, I like to make kind of these market bets first in terms of geography and sector, and then figure out where there's a supply-demand disconnect when it comes to the money. And all of that has just tons of different data points. You not only have to consider in the early stages, but also what's happening in the later stages in mature industry because of the advantages that they have, and so it becomes a really complex data science problem.
But there's still subjectiveness. Ultimately, you would want to look at what the team is, right? The dynamics of the team in an early startup.
This is me coming from private equity, and I'm doing some kind of unique things in venture. Most of venture is extremely subjective. It's like you're meeting a human, and because you can't go off the data, that they might pivot into a different market. There's only so much you can do from a data perspective. And entrepreneurship, I don't know how many of you are entrepreneurs here, but it's very difficult. It's just, there's a lot of personal growth. Can you handle the uncertainty? Can you kind of hack it, take the, you know, and endure the very painful personal growth that's going to be required to, you know, kind of forge your own way. And so because of that, a lot of it has to do with like the venture guy sitting across from the founder, just having a gut feeling that that person can do it. You know, that they can trust that person, that basically their money is in good hands with that person. And that's because, you know, I, as the venture person, also everybody's answering to someone. You know, I have investors, and so I have to perform for them and all of that. But that said, one of the reasons that I got globbed onto the data, you know, this very social, human, subjective piece of this is also why all of our innovation capital remains in homogenous networks. Like, women are getting 2% of funding, blacks 1%. Energy, also very small amounts of innovation funding outside of kind of the two poles of research and mature industry. And it just has to do with, oh, I'm a human and I don't intuitively understand that. My gut doesn't feel right when I talk to this thing that's foreign to me, you know? And so I think that we need more and more data to inform the decisions that we make at the beginning, because that's the only stuff that you see in the economy is stuff that started somewhere, you know?
Yeah, that plays into, you know, maybe someday the gut feel can be codified using deep reinforcement learning, but then that is the bias that everybody talks about in AI as well, right?
Yeah.
But bias is good and bad. You know, it can be good bias for decision making, but it can be bad bias as well. In
Yeah,
AI.
it's not something we fully understand.
Okay.
There you go.
Any other questions? All right.